A lot of 9.3 and 9.4 you can pretty much do as long as you have a formula sheet. I'm not going to worry, and a calculator. I'm not going to worry too much about that. It's kind of like an extension of 9.1 and 9.2, but we'll go over it. We're just not going to go over it right now. Let me check and see how many people are Skyping in. Gracious 6. Let's see. Mr. Crittenton. Mr. Stores. Mrs. Fuller. Weber. Let's look. Okay, one thing Ms. Fuller says.
I'm here.
Oh, you're here, but it says you could not be reached. Oh well, I think I got everybody. There's supposed to be one more. Stores, Crittenton, Fuller, Lovin, Weber. I'm missing somebody. I guess not. Just give me a second. I'm going over the text messages. Okay. Crittenton, Sorrell, Fuller, Weber. Okay. All right. I think everybody's here. All right. Don't forget to mute your microphones and just holler if you got a question, okay? Y'all should be able to see my desktop. Everybody's be able to see it. If not,
Yep.
Let me know. And I've already started the recording. As I told the class, the 3 or 4 people that's here today, we're going to do a little bit of a skip. I'm going to have to use my finger because the pen is dead. We're going to, I'm just going to go ahead and tell you 9.1, 9.2, 9.5, 9.6. It's pretty much going to make up 80% of the test. Okay? I'm going to skip. I'm going to cover these 2 for the next week, and then I'm going to come back to 9.3 and 9.4. Okay? And we'll come back to that. 9.3 and 9.4 is a continuation of 9.1 and 9.2, but if you have an identity sheet and a calculator, you pretty much can do that. So I'm going to just kind of push that off right now and get to these 2 because I want to spend more time on these 2 than these, because these 4 are going to follow you to calculus more than this. I mean, you're going to see some of 9.3, I think, which is more identities. But again, you'll have an identity sheet you'll be able to refer back to. So Today we're going to start with a little bit of review over algebra. Now, if I was to ask you to solve x squared plus 4 is equal to 0, I'm sorry, not x squared plus 4, x squared minus 4. All right, there's several ways that you can do that. All right, you got to reach back into your algebra toolbox and decide which one to do. One, you can say x squared is equal to 4. Take the square root of both sides, and x is equal to positive or negative what? 2. So you know that the x-intercepts are positive and what? Negative 2. All right, so that's one way to do. But you're reaching back into your toolbox. Here's another way you could do it. You could use reverse FOIL or the shortcuts. Reverse FOIL or shortcuts. And that would give you shortcut number 3, which is a squared minus b squared is equal to a plus b times a minus b. And you would say, okay, that would be x squared minus 4. So take the square root of that term and the square root of that term. That's going to be x plus 2 times x minus 2. So that's another way you could solve that equation. Another way you could solve it is using complete the square. Now we don't have a b term, but you can still go through the whole thing of complete the square. Okay, this isn't going to work. I'm going to have to get this. Okay, number 3. The x squared plus 0x plus blank is equal to 4 plus blank. 0 divided by 2 is 0. 0 squared is 0. Put a 0 there, put a 0 there. X plus 0, quantity squared using the shortcuts, is equal to 4. Your vertex is 0, 4. Vertex is 0, negative 4. Take the opposite of both. Solve for x. X plus 0 is equal to positive or negative 2. X is equal to positive or negative 2. And there's your x-intercepts, and your y-intercept is 0, 0. And then, of course, the fourth way you could do it is what I never use, the quadratic formula. And I'm not going to show it to you because that was drilled in your brain for 2.5 years of high school because they didn't want to teach you any other way because you had to think on the other 3 ways. On the quadratic formula, all you had to use was what? Your calculator. So I'm not going to teach that. I'm not going to go over that because I really don't want you to depend on your calculator. So, what about one like this? Let me give you another problem. And let's see if you can, not using any of these methods, but let's see if you can solve this problem. X squared minus 2x is equal to 0. Are you going to the College of Charleston? That's where my daughter is.
Oh, really?
And she's wanting to come back home. She's going to try to transfer to Clemson.
Yeah, I want to go to Clemson.
I told her, I said when she went down there, I said that highway's going to get long. Nah, I'm going to stay down there for 4 years. I'm writing down all these little things that I've told her, and she's completely denied. I told her she would change her major 5 times. She's on number 3. I told her she would come home after a year, after 2 years. I wrote that down. I just love writing these things down.
There's a book. I think my mom's got it. The title of the book is literally Shit My Dad Said. And it's like full of stuff like that.
Yeah. And it's true, because your parents know more than you do. Although when you're 18, 28, especially guys, you can't fathom that because you know everything. No offense. Present company. Oh, come on. All right, you can solve this one the same way you can solve it complete and square, but what else could you do? Well, factoring out, and this is another way. Don't pronounce it. Let's say this is number 4, or let's say this is 4 and number 5 is, this really should be like number 1. But anyway, you have something in common, you factor it what? You factor it out. And now you have x is equal to 0, and x minus 2 is equal to 0. X is equal to 0, and x is equal to 2. Those are your two x-intercepts. Your y-intercept is 0 because c is 0, but you don't know your vertex. So you can go back to your handy-dandy complete and square and go x squared minus 2x plus blank is equal to 0 plus blank. Half of 2 is 1. 1 squared is 1. Shortcut number 2, x minus 1 quantity squared is equal to 1. Now your vertex is 1 comma negative 1. Now you got your vertex. And if you wanted to, you could solve it for x and get these two again. Take the square root of both sides. X minus 1 is equal to positive or negative 1. X is equal to positive or negative 1 plus 1. What's 1 plus 1? 2. What's negative 1 plus 1? And that's your 2 x-intercepts. Now you should be fluent. You should be able to go through all of these methods without a hesitation whatsoever. Not only for algebra, but for trig, because now we're going into the trig equalities, or the trig equations, and you should be able to maneuver. But what you're going to do is you're going to see the trig, and you're going to go, I don't know how to do it. Which you do know how to do it because you know how to do this right here. Now let's do a couple more examples just to knock your memory loose. Hold on while I play on this. All right, let's do 2x squared plus 4x minus 3 is equal to 0. Now see, that is an equation that you're going to have to do complete in the square because it's not factorable. So take the 3 over to the other side. Have we reviewed complete in the square? That's a yes or no question. It's not rhetorical. Mr. Crittenden, do you remember us doing it since you talked to me? You're about the only one that'll talk to me.
Yes.
Do you remember going over completing the square in here?
The FOIL and such?
I did reverse FOIL,
yeah.
I did the shortcuts, and I did complete the square, but did I do it in here?
Maybe not right here, no.
Nobody remembers me going over it in trig? Well, I'm going over it now. Once you move the 3 over, you add these blanks. Then you factor out the 2. Because you cannot complete the square unless this number is a 1, a positive 1. So I'm going to factor out a 2. make a note here. Whatever you factor out, you have to multiply by the right side blank. Make that note. If you factor out a -1 here, multiply that side by -1. If you factor out a -1/2 here, you multiply this blank by -1/2. If you factor out a 4 here, you multiply this blank by 4. Now you can complete the square. I'm going to put this in red because this is actually completing the square, this step right here. Take this 2, you always divide it by 2, and you square it. B divided by 2 and square it. That's the actual completing the square. Now what is 2 divided by 2 squared? Then you put 1 here and 1 there. And that's how you complete the square. And that will always give you shortcut number 1 or number 2, depending upon that sign on the left. And that's going to give you x plus 1 quantity squared is equal to 3 plus 2 is 5. And at this point, you have your vertex. Vertex is the opposite of both numbers. I love it when I say the opposite of both numbers because I always get a student say, what numbers? Well, there's only 2 numbers there. Which way do we read? Left to right, Hubert. Then this is the horizontal shift. That's the x, -1. And this is the what? Vertical shift, which is your y. So there's your vertex. Now to continue to get your x-intercepts, you just solve. Take the square root of both sides. You get x plus 1 is equal to positive or negative. Well, the square root of 5 is 4.1, 4.2. How do I know that? Because the square root of 4, I'm sorry, 2.2. The square root of 4 is 2. So the square root of 5 is 2.1 or 2.2. And x is equal to positive or negative 2.2 minus 1. And that's 1.2 is one x-intercept. And then negative 3.2 is the other x-intercept. The y-intercept is negative 3. Now that you've got all this information, negative 1, negative 5. Negative 1, 1, 2, 3, 4, 5. Here's your vertex. Your y-intercept is negative 3. Your negative 3.2, 1, 2, 3.2. And 1.2, 1, 2. Oops, 2 right there. And there is your parabola. All right, let's try another one. I'm just going to put one up and then you decide how to solve it. Give me a second, I got to do it in my head right quick. Now you know it's not a shortcut. How do you know? Do I have to go over the shortcuts too? I shouldn't have to go over the shortcuts. Because they're not perfect what?
Perfect squares.
Perfect squares, thank you. The 3 is not a perfect square. So you know you can always fall back on complete the square, or you could use the reverse what? FOIL. I don't pronounce FOIL. There's a story behind it. But I don't pronounce any word with FOIL, with OIL in it. Alright, so X and X, 1 and 3. We got to have a negative, so therefore the negative will go with the 3 because it's the biggest number. And this says like or unlike? Unlike, so that's a positive. So X plus 3 is equal to 0. X minus 3 is equal to 0. I'm sorry. I don't know where that 1 turned into a 3. I don't know how that happened. Must be the alcohol. 1, that'd be a negative 1, and that'd be a positive 3. Question. Now you don't know the vertex because you know the y-intercept, but you don't know the vertex because that's what complete the square is for. All right, let's try another one. Yeah, I could do that. That would be the best way to solve this one. Factor out of 2x, Hubert. That's right, class. Thank you for the interaction. So that's our review of algebra. Capiche? Now, what does that mean? That means I'm going to revert back to trig. Hopefully I can pull up one of these. All right, let's look at this one. Do number 1. And if you can't do it, just consider yourself what? A failure or a loser, either one. Now you should be able now to go from algebra to trig and not skip a beat. No, you're going to sit there and stare at it for 15 minutes. What am I supposed to do with that cosine squared? Go ahead and do number 2 while you're at it. This problem right here is just like that. Four cosine squared of x minus 3 is equal to 0. 4 cosine squared of x equals 3. Divide by 4, divide by 4. Cosine squared of x is equal to 3/4. Now what? And cosine of x is equal to the square root of 3 over 2. Now what do you do then? Well, the square root of 3 over 2, I'm going to just continue this. Cosine of x is equal to the square root of 3 over 2. Well, that's a special what? That's a special angle, Hubert. Oscar had a hump. A hump. Which special angle has the square root of 3 on the bottom? 30-degree angle, Hubert. That's right. So that's 30 degrees. Make sure I did it right. I was doing it in my head. Now, what about here? What can I do here first? Divide by square root of 2. You got sine of 2x is equal to 1 over the square root of 2. Sine of 2x is equal to the square root of 2 over 2. I don't know if they want you to take that down further. I don't think you can unless you use identity. But right now, I just want you to just get the feel of the, I don't even know who wrote this worksheet, but the reason I picked it is because it's got some basic algebra from the transition from algebra over to trig that I wanted you to see. I don't care about getting the final answer on this worksheet. All right here. This is just like 3x squared minus 1 is equal to 0. I'm trying to get everybody to see that the algebra content that you learned in Algebra 2, Algebra 1, Algebra 2, college algebra, it's in these problems. 90% of it's in these problems. The only thing that's different is the trig, in which all you got to do is just bring it down. All right, so let's take this one. And that's going to be 3 cotangent squared of x is equal to what? 1. Divide by 3. Divide by 3. Cotangent squared of x is equal to 1/3. Take the square root. Cotangent of x is equal to the square root of 1, which is 1 over the square root of 3. So that means the tangent of x is equal to what? And that is what? Oscar had a hump of apple, so that means of apple, the square root of 3 over 1, so that means 60-degree angle. Right?
Yes. 60.
I've known people that have gone through Algebra 1, Algebra 2, college algebra, and they get to this part, and they just sit there and do what? They stare at it. You have to make the transition. You have to see the transition. You get scared. Oh, okay, that's algebra we did back in college algebra. No, because you're focusing on what? What's your eyeballs focusing on? You're focusing on what? The trig, and you're not even acknowledging the algebra. Okay, now you have to be careful on these. These right here can get you. So make a little star on this one. You don't divide by cosine. I'm going to erase this because you should have it. Wow. I don't know what I did. Oh, I did the whole thing. All right, so do this one. What would you do if you can't divide by cosine? What else could you do? And you don't want to make it more complicated by taking
Is that a square or
a cube. So what can you do? Quit? Probably the best thing to do is quit, not even try it. Erase the cube. That's probably the best thing to do. What's the only other thing you could do? Set equal to what? Yep. Now you have what in common? Cosine, bring it out. Now you have cosine squared. X minus 1 is equal to 0. Now you've got shortcut number what? Shortcut number 2, 3. Difference of two squares. A plus B, A minus B. So now you've got cosine of X is equal to 0. When is the cosine, that's the X part, the horizontal part of your unit circle, when is it 0? 0 and what? 180. 0 and pi. So 0, that's 0 degrees and 180 degrees. Or pi and 0. 0 and pi, I'm sorry. Whatever. Alright. Okay, what about this one? Well, cosine plus 1 is equal to 0. Cosine minus 1 is equal to 0. And then finish that out. When is the cosine equal to negative 1? Pi over 2 and what? 3 pi over 2. When is the cosine equal to 1? You just got it. When is it?
When cosine negative 1.
0 degrees. So you got 3 different areas. One's in the first quadrant, the other one's in the first and the second quadrant, or the first and the second, and this one right here is in the second and the third. I'm not really worried about this right now. Let's not worry about that right now. I just want you to see the transition. Try this one. Try number 5. All right, what can you do on this one? So the sine of x is equal to 0. When is the sine of x equal to 0? Well, that means that your y is 0. So that means what? 0 and 2 pi. I mean 0, 2 pi, and
360.
pi, right? Okay, so that's that. Pi and 0, or 2 pi. So there's your 2 right there. And then this is 1 minus 2 cosine of x is equal to 0. Negative 2 cosine of x is equal to what? Negative 1? Divided by negative 2, cosine of x is equal to what? 1/2? All right, now think about that one for a minute. Oscar had a hump. So that's 1 over 2. So that would be what? 60 degrees? Y'all check me. Now, where is cosine positive? All students take what? All students take calculus. Is that 1/2 positive or negative? So that means it's in those 2 quadrants. Now, I'm adding some things as I go because that way, one, you make the transition from what? From algebra to what? To trig equations. 2, you look at the answer, look at the solution and determine, solution period, and determine the angle. We did that in the first couple of problems. And then third, determine the what? All students take calculus. You need to make sure you know which one's which. So instead of just solving equations, you're solving equations. You're finding the angle of the measure of angle, and you're finding the quadrant. All right, try number 6. Number 6 is the one you tested on a good bit because it's a what? It's a trinomial or quadratic, Hubert. That's right, class. You see who Kaepernick blames for him being unemployed? Trump. He blames Trump.
Because personal responsibility is a thing, right?
No, personal responsibility. You're not supposed to be accountable for anything. When the when the tough gets going, you blame it on somebody else. Isn't that what it is today? I like that answer. Shouldn't be. Integrity, accountability, self-awareness. No, we don't need it. Just whenever something don't go our way, what do? Blame somebody else. Let's see, there's a pattern. Hold on. Let's see, Hillary blames everybody else.
That's basically what her book was all
I
about.
know.
Yeah.
Let's see, Kaepernick blames Trump.
That Hillary book too.
He's already in, yeah, he is. He's already met with people. You would be a moron to buy his book. There's somebody else blaming everybody. Can't remember who the other one was. I wrote a post on Facebook page, my Facebook page the other day. Somebody else is blaming somebody else. Yesterday, I was feeding the pigs, and we've got a boar, and he's got some big tusks. We got two boars, but one's old and the other one's new. And his tusk got caught in the fence. In the box, you know, he's got little boxes. And he could not get his tusk out because the tusks go this way. So you got a 400-pound boar screaming to the top of his lungs. And you know, I don't care how big the boar is, they shriek when they scream. It just like pierces your eardrum. And the reason he got, and I had to take, my mother was down there. She said, well, what are we going to do? I said, well, I'll take this pry bar and I'll pry the wire open, bend it open so he can get his teeth out. And I finally it took about 15, 20 minutes. The whole time that dadgum boar is screaming to the top of his lungs. Anyway, my mama asked the question after we got him free, and actually we got him free and he went over there and kept eating. I mean, it didn't bother him at all. Anyway, she said, well, how did he get, this is the gate. Well, who left the gate open? I said, I did. So I just want to take that down for accountability. I fessed up. It was my fault. It wasn't Clinton's fault. It wasn't Trump's fault. It wasn't Kaepernick's fault. I got to go back and look at my post. There was one other person that I named, and I can't remember. It's driving me crazy. All right, y'all finished yet? Well, what is it? Well, let's try reverse FOIL. Let's see, 2 sine of x, that would be sine of x. Oops. Parentheses, and 2 sine of x. Well, there's a black parenthesis right there, you just couldn't see it. I'll tell you what, I'll show y'all how good I am. There you go. Y'all like that. All right. 1 and 3. Well, we got to have a combination of 1. I'm going to put a little 1 here and a little 3 here, and I'm going to draw my outside and inside lines for my O and my I. Outside is 3, inside is 2. Can we get a 1, a negative 1 from a 3 and 2? Yes. But if you switch it around and put a 3 here, I'm going to do it in red. If you put a 3 here and a 2 here, what you going to get? What's 3 times 2? And what's 2 times 1? So you're going to get an 8 or a 4. So you can't use the 3 and the 2 in that order. You have to use, 3 and 1. 1. Sorry. You get a 1 and a 6. That will be a 7 or a 5. So there's no way you can use the red numbers. So you have to, this is called trial and error. You remember doing this in reverse FOIL? Trial and error. So we've got a 1 and we've got a 3 here. We want a -1, so that means the biggest number has to be negative. This means unlike, so that's positive. So the sine of x plus 1 is equal to 0. And 2 sine of x minus 3 is equal to 0. Sine is equal to 1. 2 sine is equal to 3.
Would it be -1 or positive 1?
Thank you. Thank you. And then sine of x is equal to -1. Now the sine is the y, the vertical. Where is sine -1? 3 pi over what? 3 pi over 2. Sine of x is equal to 3 over 2. And that, you just have to do the inverse sign on your calculator, because it's not a radical. I'm just going to try something. I don't know if it'll work or not, but let's try it. Somebody, y'all got that written down?
Yeah.
Got that written down. Where is my whiteboard? All right, what was that problem? 2 what? 2 sine squared x minus 1 sine x minus 3 is equal to 0. 2 sine of x minus 1 sine of x plus blank is equal to 3 plus blank. Factor out of 2, and that'll give you sine squared of x minus 1/2 sine of x plus blank is equal to 3 plus 2 times blank. 1/2 divided by 2 over 1 and square it is equal to 1/2 times 1/2 squared is 1/4. 1/4 squared is what? 1/16. So that's going to give me 2 times sine minus shortcut number 1 sine of x minus 1/4 quantity squared is equal to 2, that'll be an 1/8. 1/8, and this is 24/8. 24/8, that'd be 25/8. And then the vertex, but I'm going to go ahead and solve it. Be divided by 2, multiplied by 1 over 2, which would be a 16th. So take this out. Oh, shoot. Thank goodness for undo. Take that 8 out, and that 2, and this becomes a 16th. Take the square root of both sides. That's going to give you sine of x minus 1/4 is equal to positive or negative 5/4. So the sine of x is equal to positive or negative 5 plus 1 over 4. And what's 5 plus 4? 9 over 4. And what's negative 5 plus 1? Or negative 5 plus 4? Being minus 1/4. I think I got something wrong there, but there's your 3 halves. Didn't we have 3 halves as in the answer on the previous problem? One of them's right, one of them's wrong. I think I got something wrong. Oh, that's a minus 1. This is a minus 1. Hold on. What's 6 over 4? That's 3 halves, right? That'd be 6 over 4. Okay? And then negative 5 plus 1 is negative 4. Negative 4 divided by 4 is what? Negative 1. And that should be what we got on, y'all check me. We should have 3 halves and negative 1. Somebody check the previous page. Is that what we got?
The negative 1 would be 3 pi over 2.
Hmm?
Like, because you got the 9 minus 3 halves, but then we got 3 pi over 2, right? So that would be the negative 1, right?
We didn't get 3 pi over 2, it was just 3 over 2. Check. Hold on. Negative 1. 3 over 2. Again, I'm trying to show you that you can do these trig. You can do these trig equations if you just remember your algebra. And this is one of the prime examples of 90% algebra, 10% mu. This is a prime example. This section, 5.1 or whatever, 8 point, what is it? I don't even know what, 9.5 and 9.6. The prime example of 90% algebra that you know, and then 10% mu. In this case, trig, next semester will be calc. And they'll introduce the calc, and then you'll do 90% algebra. So if you suck at algebra, you're going to suck in this section as well as calculus. So make sure you know your algebra. And the review, if you need to review on something, let me know, and I'll give you some sheets, or I'll take you to somewhere where you can review on it. Okay? Let's see, we got another one in here. Any questions from the Skype crew? Y'all good?
Yep.
Yeah, they're asleep.
Yep.
All right, look at these two, 7 and 8. I'll let y'all do those. Give you 6 minutes. Let me pause the recording so I can forget to turn it on later. And if you're kind of stuck and you're just sitting there staring at it, the first one we can do by reverse FOIL or by completing the square. So I'm not going to do anything on that one. This one you got to rewrite. Cosine squared x minus or plus sine x minus 1 is equal to 0. That's not going to help anything because that negative 1, it ain't going to help anything, so you need to bring it over. You're going to have to do this one by, no, you can't. I want to take the square root, no, you can't take the square root, because that can mess you up. We'll come back to that one. This one, cosecant squared, let's see, we can, let's see, 1 and 2. Yeah, this one is factorable. Cosecant x, cosecant x, equals 0, 1 and 2. We want a negative, so that means the 2 is bigger, so it has a negative. This is a negative, which means unlike. So cosecant x plus 1 is equal to 0. Cosecant of x minus 2 is equal to 0. Cosecant of x is equal to negative 1. Cosecant of x is equal to positive 2. That's positive 2 over 1. This is negative 1 over 1. So if I wanted to flip it, what's the reciprocal of cosecant? Sine x is equal to negative 1. Sine of x is equal to what? 1/2. And now you know when is the y of your unit circle negative 1? 3 pi over 2. When is the sine 1/2? Oscar half. Well, that's when it's 30 degrees, isn't it? Oscar, no. Sine of 1/2, you just have to punch it in your calculator. I thought it was, no, it's not a special angle. Is it?
It's 30 degrees.
Is it 30 degrees? Okay. Yeah, no. Yeah, Oscar half. Yeah, that's what I was thinking. This was bothering me. Now, what I do, when I get to one that bothers me, this is what I do. I take my handy-dandy eraser, and I will try to write it in a way that reverts back to algebra. I'm just going to say x squared equals 1 minus y. I don't see anything that I can do there. Even if I squared both sides, that's not going to help. If I brought the 1 minus sign over, that's not going to do any good because the cosine and the sine, you can't reverse FOIL with the cosine and the sine. Only thing I'm going to do is take the square root. And I don't know why they're putting this in here. I mean, I don't know, like I say, I don't know. That'd be cosine x is equal to the square root of 1 minus the sine of x. Unless somebody else has another idea. I don't see anything that really you could do. Can't use conjugate because you don't have there's no, I think that's the answer. I don't know what the answer is because I don't know the sheet, but anyway. Now, what's the difference between the first 8 that we did and these? These are telling you what? The area to what? To limit yourself to. So, in this question, square root of 3 plus the tangent of 2x is equal to 0. You solve it, and then you ask the questions that we've been asking about where's the angle and what quadrant is in. Now you're told you can go from 0 to 2 pi. So it's in the 360 degrees. So minus square root of 3, so that'd be tangent of 2x is equal to the square root of 3. And I'm not going to go any further than that because we don't, that's a double angle. We'll get back to that. I want to really focus on 1 through 8 right now. Okay? So right now, on 9.5, go to 9.5 right quick. We already covered one like that. We covered one like that, so I'm just going to keep going. And that's showing you where there we already talked about that. You're going to have different angles of the same sine and cosine, so we already talked about that. Solving. There's another example. All right, do this one. Solve sine tangent is equal to sine. Again, you can't divide by sine. And this is where you get into, and my calculus students will tell you that I teach this. Y'all ever seen this on the internet where you, I don't feel like going through that thing, so I'm just going to use this board. Y'all ever seen where the teacher puts find x and they have a 2, 3, x, and the student goes, here it is. What's wrong with this? Okay? What's wrong with it? When you do something like that, what does your gut tell you? That it's not going to be correct because it's too what? It's too simple. Usually when something is too simple in trig and calculus, when it's too simple, that means what? It's not going to be correct. All right? So when you get to this thing right here and you say, okay, sine of theta tangent theta is equal to sine of theta, what's your first inclination? Oh, I'm just going to divide through by sine. Well, you just did that. Okay? Now, it's kind of like when you're driving. All right? When you first start driving, everybody in here is like this. You got your hands at 10 and 2. And you got a death grip on that's when you first start driving. And you go 20 miles an hour everywhere you go. But then later on, when you graduate high school, graduate college, and you get a degree and get a job, you're going to work, putting on your makeup, holding something in one hand, and driving with your knee. Okay? This goes away. After you do so many calculus and so many trig problems, you're going to start saying, Hubert was right, it's too easy, that probably is not it. So, you don't divide through because it's not going to give you all your answers, it's only going to give you half the answer. It's only going to give you one x-intercept or one solution. So, what do? You bring that sign, what? Over. Just like in that cosine problem we did. Sine theta, tan theta, minus sine theta is equal to 0. Bring this over. Now, what if you had 2 tangent of theta is equal to 4? Well, then you would divide by 2 because that would leave you your answer. But this is not that problem, okay? So, what's in common? Factor out the sine. That leaves you a tangent, theta minus 1. So now we've got sine theta is equal to 1. Tangent theta minus 1 is equal to 0. Oh, I can't use Greek letters anymore because there's this professor at the University of blah, blah, blah that says we should not teach algebra and calculus anymore because use of the Greek letters enforce white privilege.
It's not the joke itself.
It's on my,
It's the words white privilege.
yeah, it's on my Facebook. I said, yes, and I put this on the feedback where you put comments. I said, yes, and underwater firefighting classes encourage ignorance and oppression. And it does. If you keep the public stupid, it's easier to what? It's easier to manipulate them. That's what the Democrats have been trying to do for the last 50 years, since the LBJ. Anyway, shut up, Hubert. When is the sign, when is the vertical, the sign, which is your vertical, when is it 1?
Where'd the 1 come from?
When is it 0? Smart.
Oh, no, I was really asking.
No, you're right. I messed up. I was thinking that tangent. All right. When is the sine? When is the cosine sine? When is it 0? That means the horizontal is 0. When is the horizontal 0? Pi over 2 and what? 3 pi over 2, is it? Yeah, just look on the unit circle. Okay? Tangent is equal to 1. When is the tangent of theta equal to 1? Well, that's 1 over 1. That's a 45-degree angle, right? Oscar had of apple. 1 over 1. You see where you need to learn your special angles? I don't. One of the reasons that I have to keep thinking about them is I don't memorize them. I think about them in my head. That's your answer. They're doing it right there. There it is. I said, okay, 0 and 180. You're right. I was thinking, sometimes it's aggravating thinking about the sine as the vertical, okay? So you have to think about the sine as the vertical. And 45 degrees, we got that correct. Okay? So in this problem, how many solutions do you have? You have 4. If you'd have just divided by the sine, you wouldn't have got all 4. There's an algebra example I'm trying to think of. Do you remember when you were finding your x-intercepts or your absolute zeros in algebra? And if you didn't do a certain thing, you would only get 2 when there was actually 4? You remember doing that in algebra? Same thing. Okay? All right. I got to quit because they're going to break down the door in any minute. All right. Now, what I want you to do right now, this is what you need to be working on, and that's everybody. You need to be working on 9.1, 9.2, and 9.5. Okay? 9.1, 9.2, and 9.5. Questions, gripes, complaints. All right, get out of here. See y'all.
See ya.